The definition of heat transfer conduction is the process of thermal energy transfer without any flow of the material medium. The higher temperature object has molecules with more kinetic energy. Thermal conductivity is the rate of heat transfer through a unit thickness of the material per unit area per unit temperature difference. The heat flux density is the amount of energy that flow through a unit area per unit time cube upward. The thermal conductivity K is often treated as a constant, though this is not always true. While the thermal conductivity of a material generally varies with temperature, the variation can be small over a significant range of temperatures of some common material. In anisotropic materials, the thermal conductivity typically varies with orientation. In this case, K is represented by a second order tensor. In non-uniform material, K varies with spatial location. For many simple applications, Fourier's law is used in one-dimensional form, for example, in the x direction, Qx yerf K T x. Types of conduction. Ionic conduction, the movement of an ions from one site to another. The I is possible through defects in the lattice structure of a solid or an aqueous solution. Electrical conduction can happen as a result of the movement of electrically charged particles. The movement of these free electrons is what enables metal to conduct an electrical current. Thermal conduction occurs when rapidly moving particles interact with their neighboring particles, thus transferring a portion of their kinetic energy. The process happens from regions with a higher temperature of regions of a lower temperature. Convection is the process of heat transfer by the bulk movement of molecules within fluids such as gases and liquids. The initial heat transfer between the object and the fluid takes place through conduction, but the bulk heat transfer happens due to the motion of the fluid. Convection can be classified into two types. Unnatural convection. This occurs due to the natural movement of fluid caused by temperature differences such as warm air rising and cooler air sinking. Forced convection. This occurs when the fluid is forced over a surface or through a system by an external force such as a pump or fan-like in a heat exchanger or cooling system. Equation for convection. The rate of heat transfer via convection is given by Newton's law of cooling. In forced convection, the convective heat transfer coefficient H depends on fluid properties, velocity, and the nature of the surface. Q mononfreich member A. T by S. T bombers. For natural convection, the heat transfer coefficient H can be determined using correlations involving the Rayleigh number, μRa, and Prandtl number, PR, especially for different geometries. Natural convection. Imagine a hot cup of coffee left on a table in a room. The air near the surface of the coffee warms up, becomes less dense, and rises. Cooler air from the surroundings moves in to replace the rising warm air. This continuous process of warm air rising and cool air sinking is an example of natural convection. The heat is transferred from the coffee surface to the surrounding air through convection. Forced convection. A good example of forced convection is the cooling of a car engine. A fan blows air over the radiator, transferring heat from the engine coolant to the air. The air velocity is increased by the fan, which enhances the heat transfer compared to natural convection. Heat exchanger. In a heat exchanger used in industrial applications such as power plants, chemical industries, two fluids, usually water, oil, or air flow over each other. One fluid is heated and the other is cooled, transferring heat through convection. The heat transfer is forced convection, and the rate of heat transfer is crucial for the efficiency of the heat exchange process. Heat transfer via radiation. Radiation refers to the transfer of energy in the form of electromagnetic waves, such as visible light, infrared, ultraviolet, and others, without the need for a physical medium. This means that radiation can occur even in a vacuum, like the space between the Sun and the Earth. According to Stefan Boltzmann law, the amount of radiation emitted per unit time from area A of a black body at absolute temperature T is directly proportional to the fourth power of the temperature. The process of heat transfer via radiation. Emission of radiation. Objects that are at higher temperatures emit radiation in the form of electromagnetic waves. All objects that are hotter than 0 K, absolute zero, radiate some form of energy. For example, the sun emits radiation in the form of visible light and infrared radiation, while fire emits infrared radiation that we feel as heat. Electronic waves, EM. Radiation consists of electromagnetic waves that propagate at the speed of light. Unlike conduction and convection, which require a medium such as air or solid objects to transfer heat, radiation can travel through a vacuum. Absorption of radiation. Cooler objects can absorb this radiation, increasing their temperature. For example, the Earth absorbs radiation from the sun, warming its surface and atmosphere.
Here we have an electric hot plate. When a pot of water is placed on the hot plate, the pot is in contact with the hot plate and the heat moves via conduction from the hot plate to the pot. Inside the pot, the water at the bottom is heated. It rises as it is heated and then falls as it is cooled. A current forms which distributes heat via convection throughout the pot. When held at a distance from the hot plate, heat continues to move via radiation.
Application of conduction in industries. 1. Metal quenching. The cooling process can be manipulated to adjust the phase of a material. Thermal insulation materials are used as heat lagging in industry and construction. Applications of convection in industries. 1. Power generation. Power generation, force convection, is used in heat exchanger to maintain the gradient temperature. Automotive industry, engine cooling system rely on force convection through fans or pumps prevent from overheating. Radiation drying process. Food drying infrared dryers are used to dehydrate fruits. Vegetable industrial sterilization. Gamma radiation is used to sterilize packaged food product to increase shelf life without using chemical or high heat in food industries.